Hi guys, I will explain the moment of area, part 5, from review of principal axis to summary. Here I have a quiz for you. Which one looks like the right one to describe the principal axis? Please select as one of three. I have explained all the topics from first moment of area to principal axis for rectangular, triangle, and circle. In this video, I will explain the direction of principal axis and the section shape. Remaining topics will be explained in the next videos. I explained the principal axis can be derived from the equation for the product moment of area. We can obtain the angle from the reference angle to the principal axis using the fact that the product moment of area equals 0 in the principal axis. As a result, we can get that angle by the equation 1 here. Let's find out what the relationship between the principal axis and the sine of product moment of area Izzly is. The slope tangent theta from the reference axis to the principal axis is the value obtained by dividing the y-axis component by z-axis component. Therefore, if the sine of theta is positive, the positive direction of the principal axis must pass through the first quadrant, and the direction of theta is clockwise as shown in this picture, and the sign is plus. Let's find out which direction the angle theta to the principal axis is by intuitively evaluating the sine of product moment of area Izzly. In this picture, it can be seen that the sine of product moment of area Izzly is negative because the area has mainly distributed in the second and the fourth quadrant. When the principal axis is tilted to the right, less than 45 degrees, as shown in this picture, if we calculate the theta, we can see the sine of theta is plus when Iz is greater than Iy and Izy has a negative value. It can be seen that the principal axis is located clockwise from the reference axis. Therefore, the principal axis Zp and Yp can be located theta degrees clockwise from the reference axis as shown in this picture. From this, if the product moment of area is negative and the second moment of area about horizontal axis is greater than that about the vertical axis, the rotation angle theta has a plus value, and the principal axis is located clockwise from the reference axis. Contrary to the previous case, the y component and the z component of tangent theta have different signs, so if the sine of theta is negative, the positive direction of the principal axis must pass through the fourth quadrant, and the direction of the principal axis theta is counterclockwise as shown in this picture. In the same way as before, let's intuitively evaluating the sine of product moment of area Izy to find out which direction the angle theta to the principal axis is. In this picture, it can be seen that the sine of product moment of area is positive because the area is widely distributed in the first and the third quadrant. As shown in this picture, when the principal axis is tilted to the left by theta less than 45 degrees, as shown in this picture, if we calculate theta, we can see the sine of theta is negative when Iz is greater than Iy, and Izy has a positive value. It can be seen that the principal axis is located counterclockwise from the reference axis. Therefore, the principal axis ZP and YP can be located θ degrees counterclockwise from the reference axis as shown in this picture. From this, if the product moment of area is positive and the second moment of area about the horizontal axis is greater than that about the vertical axis, the rotation angle θ has a negative value, and the principal axis is located counterclockwise from the reference axis. The cross-section in this picture represents three squares with a side of 30 millimeters joined together in a row, and is inclined at 45 degrees clockwise from the vertical axis. I will show you various types of calculation on the second and product moment of area and the principal axis with this example. After finding the second and the product moment of area about the existing axis, we will find the second and the product moment of area when the coordinate axis rotates at an arbitrary rotation angle, and then find the principal axis again based upon the rotated coordinate system to verify our calculation. In the first step, the entire section is divided into an easy-to-calculate form and locates the coordinates for the vertices of each element, like this. In this example, the whole is divided into three squares, and the coordinates of each vertex are obtained. Since the rectangle marked with green is the rotation of the rectangle marked with a thin black line, it can be obtained by using the coordinate transformation matrix, or, in the case of this example, which is very easily calculated by intuitive calculation. The second step is to calculate Iz and Iy for each element. A rhombus with the same length of intersecting diagonals is equal to the rotation of a square. So it has the same value as the second moment of area of the square. Therefore, the formula for calculating the second moment of area for a square can be used, and we can get this value. Using the parallel axis theorem, we can find the second moment of area for the rhombus APHG prime. This is the second moment of area for rhombus in the center, and this is the area, and this is the perpendicular distance from the centroid to the reference axis. EFCT prime is point symmetric with ABHG prime, so it has the same second moment of area. Because of symmetry, Iz equals Iy, which is the sum of all three values. The third step is to calculate the product moment of area. Since the rhombus GHFE prime is symmetrical with respect to both of z and y axis, the value of the product moment of area is 0. Using the parallel axis theorem, we can find the second moment of area for the rhombus APHG prime. This is the product moment of area for the rhombus in the center, which equals 0. We calculated already. This is the area of rhombus, and this is the perpendicular distance from the centroid to each reference axis, z and the y axis, which is kh prime and gk prime here. EFCT prime is point symmetric with APHG prime, so it has the same product moment of area. the entire Iz is the sum of three rhombuses. Calculating this will result in a negative value like this. If there are cross sections in the second and the fourth quadrants, one of the coordinate values of z and y axis is negative. So the value of the product moment of area becomes negative like this. As described above, the product moment of area should be 0 in the principal axis by substituting the values of the second and the product moments of area obtained in the previous slide into the equation. We can calculate the angle from the current reference axis to the principal axis. In this equation, Iz and Iy are equal. So the denominator is 0. Therefore, the arctangent goes plus infinity. The cases where the arctangent becomes positive infinity between 0 and 360 degrees are 90 degrees and 270 degrees. So 2 theta p represents the angle with respect to two principal axes. It represents theta p and theta p plus 90 degrees. In this example, 45 degrees and 135 degrees. The fifth step is to calculate the second and the product moment of area about the principal axis by substituting one of the previously obtained theta p1 or theta p2 into the three well-known formulas. We can calculate the second and the product moment of area about the principal axis z prime y prime. Substituting 45 degrees for theta, we can get the values shown in this table, where the values for the major principal axis z prime represents the maximum second moment of area in this section, and the values for minor principal axis y prime represents the minimum second moment of area in this section. The product moment of area with respect to the principal axis equals 0. In the principal axis, major principal axis has a larger value. The minor principal axis has a smaller value. In this example, the z-axis is the major principal axis, and the y-axis is the minor principal axis. Theta p and theta p plus 90 degrees represent the angles from the reference axis to the major and the minor principal axis. Depending on the coordinate system, theta p may mean an angle to the major principal axis or an angle to the minor principal axis. When the second and the product moment of area are obtained about the principal axis, the larger one is for the major principal axis and the smaller one is for the minor principal axis. Theta p is the angle with respect to the nearest principal axis within plus minus 45 degrees among the major and the minor axis. If the principal axis is exactly at the 45 degrees as shown in this picture, it is counted as a positive angle to the principal axis in the clockwise direction. This relationship will be explained again later. This time, the object rotated 30 degrees clockwise around the centroid. Let's find the second and the product moment of area in this case. Since the rotation of the object is in the opposite direction to the rotation of coordinate axis, the value of theta in our equation is negative and counterclockwise. Substituting the Iz Iy and Izy obtained above and 30 degrees per theta into the well-known three equations, we can get the second and the product moment of area with respect to the zy prime axis. A 30-degree counterclockwise rotation in the previous slide is equivalent to a 75 counterclockwise rotation of the principal axis. This time, let's calculate based on the principal axis and verify that it is consistent with the previous result by substituting the values of principal axis into the related equations and the counterclockwise rotation angle of minus 25 degrees. Three values can be obtained like this, which are the same as those obtained in the previous slide. We calculated the second and the product moment of area about an axis rotated counterclockwise at an arbitrary angle of 30 degrees from the reference axis. This time, using the calculated coordinate system rotated by 30 degrees as the reference axis, we calculate the position of the principal axis and verify whether the principal axis has the same value as the previous result. Since the product moment of area Izy prime becomes 0 in the principal axis, therefore this equation should be 0. Substituting all the values Iz, Iy, and Izy, we can get the angles to the principal axis, minus 15 degrees and 75 degrees. By substituting as one of the angles into the well-known three equations, we can get the second and the product moment of area about the principal axis. The angles for the position of the principal axis are the angles between current coordinate system and the principal coordinate system. And the same values are calculated for the second and the product moment of area, no matter which one is substituted, by substituting minus 15 degrees into the equations. Z prime becomes the minor axis, and the Y prime becomes the major axis. On the other hand, if 75 degrees is substituted in the equations, Z prime becomes the major axis, Y prime becomes the minor axis. Therefore, the smaller absolute value is the angle with respect to the closest principal axis within plus minus 45 degrees, regardless of whether it is a major axis or minor axis. If it is 45 degrees, the angle value is positive. The one with the larger second moment of area is major axis, and the one with the smaller second moment of area is the minor axis. The correct answer to the quiz is number 1, because the product moment of area equals 0 about the principal axis. Therefore, all the areas are equally distributed in each quadrant of the coordinate system in the principal axis. Neither number 2 nor number 3 is the answer, because the cross-section is widely distributed in the first and the third quadrant in number 2, and in second and the fourth quadrants in number 3. Here we have summary. Steps to find the principal axis and calculate the second moment of area on the principal axis are: get the coordinates, find the second moment of area, find the product moment of area, calculate the angles to the principal axis, calculate the second moment of area about the principal axis. Two angles, theta p and theta p plus 90 degrees, are calculated for major and minor axis. The small absolute angle, theta p, represents the nearest principal axis within plus minus 45 degrees. The principal axis with a larger second moment of area is called major principal axis, and the smaller one is called the minor principal axis. The major and the minor principal axis, respectively, have the maximum and the minimum second moment of area that the cross-section can have, and the product moment of area equals 0 with respect to the major and the minor axis. If you watch the previous videos, you can easily understand upcoming videos. In the previous video, E0044, I explained the second and the product moment of area about the triangle and the polar moment of area for a circle. Recently, I explained the direction of the angle to the principal axis and how to find the principal axis. The next video will be Pleister, Part 17, Moment of Area, Part 6. I will explain the Mohr circle and the principal axis. Please hit the thumbs up and catch the brand new videos by free subscription. So, what are you waiting for? See you in the next video. Goodbye, guys.